Okay, good morning class. Alright. So for today, okay, good morning Junyuan. Alright, so for today I will continue for the discussion, right? For the tutorial questions. Okay, so I still have the names, okay, for those who still didn't answer. So we only continue, okay, for this, okay. Alright, so let's see who will answer for the next question. Okay, Misha Sim Chian Yi. Okay, right. So you are here, right? So what's the answer for this one? Okay, for D. Okay, what is the type of the current supplied to each house? Okay, there are two types of current. Okay, the first one is the alternating current and another one is the direct current. So which type of the current that we receive, okay, in our house? Yes, alternating current. Okay, so for this one, the answer is alternating current. Okay, so the next one. Okay, Ng Kok Sheng. Alright, Ng Kok Sheng. Okay, so what is the answer for E? Okay, it says here the toaster in diagram 2 uses a 2-pin plug. So why does the use of the toaster is less safe, right? So usually if you want to be safe, it's better for you to use the 3-pin plug. Okay, so what is the difference between 3-pin plug and 2-pin plug? So toaster has not got fuse and the earth wire. Okay, for the 2-pin plug, okay, it doesn't have the earth wire. Okay, so you can put a fuse. Okay, for the fuse, you can put inside in the 2-pin plug or 3-pin plug. Okay, but the only difference between 2-pin plug and the 3-pin plug is the earth wire. Okay, so because it doesn't have the earth wire. Okay, it doesn't have earth wire. So if there is a lead current, okay, it will not flow to the ground. Okay, so that's the answer. Okay, so they don't have the earth wire. So means if there is no earth wire, if there's any leakage of current, okay, so there will not be flow to the ground, right? It will make, let's say, it will cause a fire, okay, or maybe it can cause a short circuit. All right, so this is the answer for question for E. Okay, so very good. All right, so let's move on to F. Tan Mei Jun. Okay, Tan Mei Jun. Are you here, Tan Mei Jun? Okay. So what's the answer for question F? So what is, you have to state the 2 steps, okay, to prevent the electrical accidents. So what you should do, okay, they say when you switch on the current, what you should do, what you shouldn't do. Can you connect too much of the electrical appliance, okay, by using only one switch, okay? Or maybe can you touch the electrical appliance, okay, with your wet hand? Using the appliance in the same socket of the same time. Yes, correct. Okay. So avoid using all appliance, okay, on the same socket at the same time. Okay, then another one. Install solar panels to replace the electrical energy. Okay, that one is actually for saving electricity. Okay, if you use a solar panel, okay, so that one is actually to save the electricity, but this one is to prevent the electrical accidents. Okay, so you can say that do not switch on, right? Do not switch on, okay, the switch, okay, when your hand is wet. Okay, so you cannot touch the electrical appliance or the switch when your hand is wet, because you know that when the currents can flow, okay, by water, right, using water. So here it said do not touch an electrical appliance when electrical appliance, okay, with wet hand. Okay, because current can flow through water. Right, so 2 marks. Okay, for number 5, okay, this is the calculation question. So it says here, complete table 1 by calculating the total current which flows through the electrical appliance. So you can see here they give you a power and they give you a voltage, right? So what's the formula that you should use? So you should use P is equals to VI, right? Okay, Wen Jiao Hao. Are you here, Wen Jiao Hao? Wen Jiao Hao? Okay. I forgot to remove it. Okay. Alright, Wen Jiao Hao, what's the answer for these three? Okay, these three questions. Just give me the answer for the air conditioner, the iron, and also the stand fan. 8.3. Okay. Is that mean that when you calculate it, the answer give you the 8.3? I think it give you a long answer like 8.33333 something like that, right? So when it happen like that, you give the answer in 2 decimal or 3 decimal point. Unless when you calculate, yes, it give you 8.3. Exactly. No decimal point. Okay, only 1 decimal point. Then you give the answer in 1 decimal point. But let's say the answer you use a calculator is give you a very long answer. Okay, then you have to round off to 2 decimal point or 3 decimal point, right? Yes, good. So 8.33 ampere. Okay, and this one is 4 point, I think 4.17, because 1000 divided by 240. 1000 divided by 240, you will get like 41.16666, right? So you have to round off to 2 decimal point. Okay, so it should be 4.17. You got like this, right? 6666. Okay, you round off to 2 decimal points. So this one more than 5, you have to add 1 here. So 6 plus 1 is 7. So 4.17 ampere. Okay. All right. So the next one is 8.33. Okay. So 75. Are you sure 8.33? 0.31. Okay, correct. Yeah, so this one is 0.31 ampere. Okay. So make sure you round off it. Okay. If 2 decimal point, you have to round off. Okay. And make sure if the answer give you more than 1 decimal point, you have to take until 2 decimal point. Okay. Right. Very good. Okay. So let's try for B. Okay, Pavandit, what is the answer for B? Okay, they ask you to determine the suitable fuse. Okay, Pavandit, are you here? Yes, right. So what's the answer for this one? You have to choose what is the suitable fuse, okay, for each type of the electrical appliance. So this one you have to refer to the currents, okay, that flows, right, based from the table 1. Okay, you have to choose. All right, 8.33 correct, 10 ampere. Okay, you have to choose higher than the current flows. Okay, cannot choose 8 ampere or 5 ampere. Okay, because if more than because the current if flows more than 5 ampere, the thin wire inside the fuse will melt, then it will cut off the electricity, right? So the iron is 5 ampere. Yes, very good. 5 ampere. And the stand fan is 1 ampere. Yes. So for the fuse, please remember you have to choose higher than the current flow, right? If not, the fuse will melt. Okay, the wire inside the fuse will melt, and this will cause the electricity, okay, cannot flow, okay, through the electrical appliance. This one I actually fuse is the for the safety features. Okay, fuse and the earth wire inside the plug. Okay, is actually for the safety reason. Okay, for C. Okay, Pua Qian Hui. Right, what is the answer for I? Oh, sorry. Just yeah. So what's the answer for C1? Ask you to calculate the electrical energy. So you use the formula E is equals to PT, right? So the power is, what is the power here? Okay, so refer back to the table here. The power is 2000. Okay, and the time here is 30 minutes. Okay, so you have to change to hour by divide it with 60. Okay, because you know when you want to calculate the cost of electrical energy, your answer must be kilowatt hour. So means the unit for the power must be in kilowatt and the time must be in hour. This one is only if you want to calculate the cost of electrical energy. But let's say for the you normally let's say they ask you to find the energy, right? Electrical energy, okay? Then you have to put the power is watt and the time in second. But if you want to calculate how much you need to pay, okay, for the month, for the bill, that one you have to change to kilowatt hour. So what is the answer here? 0.2. Okay, so E is equals to PT. Okay, the power is 2000, right? So if I change to kilowatt, should be 2000 divided by 1000. Okay, I have to change to kilowatt first by divide it with 1000, and the time here is 30 divided by 60. Okay, so I should get 1. Okay, 1 kilowatt hour. Okay, so here it already said, right, the cost of the electricity for 1 unit is 20 cents. So you just multiply with 20. Because this is 1 means the energy means 1. So 1 times 20, you will get 20 cents here. Okay, very good. For the iron, Chen Wai Hong. So only 2% left, right? Chen Wai Hong, are you here? Chen Wai Hong? Chen Wai Hong? Chen Wai Hong, are you here? Okay, Chen Wai Hong is not here. So the next one is Lua Ming Sun. Okay, Lua Ming Sun. Okay, so what's the answer for 2? Okay, the iron. So what is the power of iron? 1000. All right, so then how you will calculate? Okay, hello. All right, so how you want to calculate for the electrical cost of the electrical energy for iron? Okay, it just seemed like number 1 here. Okay, you have to change to kilowatt first, and the time should be in hour. Okay, so just use the same method, okay, to find the iron. RM 10 cent. Okay, so let's check. So the power here is 1000. So 1000 divided by 1000, and the time, okay, so it's the same, 30 divided by 60. I need to change to hour. So you will get 0.5. Okay, so 0.5 kilowatt hour. Then multiply by 20. Okay, so you will get 10 cent here. Okay, very good. Okay, so the next one, I think Wong and Tong, right? Wong and Tong, the last one. 0.038, 0.075. Okay, so E is equals to PT. Okay, so the power here, the power of the stand fan is 75. So 75 divided by 1000. Okay, and the time is 30 divided by 60. Okay, then I just multiply with 20 cent here. All right, so I will get 75. 75 divided by 1000 is 0.075, multiply by 0.5, and then multiply by 20. So I will get 0.75. Okay, 0.77 75 cent. Okay, 0.075 times 0.5 times 20 cent. So 0.75, right? And then here, wait, 0.05. Yeah. Mm-hmm. 0.075. 0.038. You multiply with 0.2, right? Is it, Entong? Yes, okay. I multiply with cent first, then later I will change to this one is 20 cents. So after this I have to divide with yeah, it should be multiplied by 0.2. Okay. So wait, I where's my eraser? Drawing. So 0.2 you will get 0.0075. So this one you have to round off, right? Like 1 cent, I think. Okay, because there's no way that we can pay like 0.075. So it should be 0.01, right? 1 cent only. Okay, then after that, it says here, all right, so all of you already answered, very good. So calculate the total cost of the electrical energy used in April if the usage of the three electrical appliance is as in 5C every day. So you just add all of this, 20 plus, 20 cent plus 10 cent plus plus 1 cent. So you will get 31 cent, right? So 31 cent you multiply with 30. So what you will get? You will get 9 ringgit 30 cents. So this is what you have to pay, okay, for April. Okay, just multiply with 30 because April have 30 days, right? So just multiply with 30, you will get 9 ringgit 30 cents. Okay, so we already finished discuss for the tutorial here. Okay, so please keep the paper. Okay, let's say you answer in the test pad, please keep the test pad. Okay, so later when the school open, you can submit to me, right? And I will mark your answer. Okay, so let's continue to the next subtopic. Okay, I think you already watched the video for the potential and the kinetic energy. Okay. But I will just go through. Okay, I will just go through for the for the energy, potential energy, and also for the kinetic energy. All right. So I will just go through what is it, all right, and the formula, okay, and also the unit, right, how you want to calculate it before I go to the principal conservation of energy, right? Okay. So actually there are, for this chapter, there are three types of energy that you will learn. Okay, so the first one is the potential energy. Okay, so there are two types of potential energy. There is a gravitational, okay, potential energy, right? And another one is the elastic potential energy. Okay, so there are two types. Okay, and the gravitational potential energy. So what is the gravitational potential energy? So gravitational potential energy is the energy due to its position, right? So it means the higher the position, the higher the gravitational potential energy. So let's say if you live in the apartment, right, and your friends stay at the first floor and you're staying at the third floor, okay, so it means you have the higher position than your friend. So you have the gravitational potential energy. Okay, the higher your, because of your position, right? Because of the position, you will have the higher gravitational potential energy if we compare to your friend. Okay, so that is the gravitational potential energy. So it's due to the position, right? And what's the formula? Okay, for the gravitational potential energy, Okay, the formula is mgh. All right. So what is m? M is the mass. Okay, there must be in kg. Okay, and then for the g is the gravitational acceleration. This one, the value is constant, that is 10 ms negative 2. Okay, and h is the height of the object. Okay, must be in meter. Okay, and for the elastic potential energy, so that is the gravitational potential energy. Okay, so it's due to its position. And for the elastic potential energy, okay, so for the elastic potential energy, usually for those who are, for the object, okay, the elastic potential energy is for the object that have the ability, okay, to return to its original position after you remove a force. So what does it mean? So let's say if I have a spring, okay, if I have a spring and I put the load, okay, at the spring. So what will happen? Of course, the spring will stretch. Okay, so it will become longer. And then let's say if I remove the load, so what will happen to the spring? Okay, it will go up, right? Okay, so it will go back to its original position after you remove the load. So you can say here the spring has the elastic potential energy. All right. The moment that you put the load and it's stretching, okay, and the spring is stretching, okay, so that moment we call it the spring has the elastic potential energy. Or maybe you can take another example like the rubber band, right? So when you stretch the rubber band, okay, so at the moment you stretch the rubber band, okay, is said to be is said to has the elastic potential energy. Okay, and then after you release, right, the rubber band will come back to its original position. Okay, so it will change to the kinetic energy because there is a movement, right? Okay, so that will become a kinetic energy. All right, so any object that can return to its original position after the force being removed, okay, that one we call it as the elastic. Okay, it has the elastic characteristic. Okay, then and the elastic potential energy is when you put the load on the spring and the spring is stretched. Okay, and that moment we said the spring has the elastic potential energy. Okay, then the formula for the elastic potential energy, okay, so the formula is half Fx. Okay, so what is F? Okay, the force applied to the system. This mean, okay, what the force? This one, let's say if I use a load, what is the force of the load? What is the force of the load? Means you have to find the force here, okay, by using F is equals to mg. Because you already know force, the unit must be in Newton, okay, and this one, the mass is in kg, right? So you have to change to Newton by multiply by 10, okay. So that's the elastic potential energy. Okay, and what is X? X is the displacement. What is the compression and or what is the stretching? Okay, so how you want to find? So let's say if I have a spring, okay, this is before I put the load. All right, the length of the spring is, let's say, 10 cm. Okay, let's say after that I put the load. Okay, so it become longer, right? So now the new, okay, the new length of the spring is, let's say, 15 cm. So X is the 15 minus 10. Okay, what is the difference, okay, before and after you put the load? So 15 minus 10, so 5 cm. So the X is 5 cm. Okay, but you have to change to meter. Okay, this one, the force must be in Newton, the displacement must be in meter. Why? Because you know already for the energy, for both energy, okay, doesn't matter whether what type of energy, the SI unit must be in joule. So after you calculate, you must put the unit joule. Okay, So if you don't change to meter, you cannot use the unit joule. Okay, you have to change the another to another unit. Okay, so this is the two type of energy for the potential energy. And then for another thing, okay, for the elastic potential energy, let's say they give you a graph here. Okay, so this is the graph, all right, and this is F and this is X. Okay, so the graph should be straight line like this and pass through the origin. Okay, so if you want to find the elastic potential energy, okay, based from the graph, you can find area under the graph here. Okay, this is also equals to elastic potential energy, right? So there are two ways to find elastic potential energy. The first one, you can use the formula here, and the second one, you can find the area under the graph. But it's, as you can see here, this is the triangle, right? So the formula for the area of the triangle is 1/2 divided by base and height. Okay, so the base here is actually F, right? And the height here is X. So if you try to simplify it, you will still get half Fx, and this is same as the formula. Okay, so it's basically a same thing. But they say they give you a graph, then you just find the area under graph. But if they don't give you a graph, they give you any value, okay, force and X, so you use this one. But remember, the X must be in meter. If not, you cannot use the unit. Okay, for energy there is a joule. Okay, and another part is we learn about kinetic energy. Okay, all the notes actually already been given in the Google Classroom, so you can refer, okay, at the Google Classroom. So what I did now, I just do a review, okay, and summarize. Okay, and kinetic energy. So what is the kinetic energy? So kinetic energy is the when object is moved, any object that move. Okay, say let's say you walk. Okay, you walk also you got the kinetic energy. Okay, let's say the ball, okay, the ball slide down. Okay, so that one also have the energy. Any object that have the energy, that have the motion, okay, we call it, we say that it has the kinetic energy. Okay, so this is energy due to its motion. Okay, due to its motion. Any object moving must have the kinetic energy. Alright, so what's the formula? Okay, half mv square, whereas m is the mass, v is the velocity. Okay, so this is the kinetic energy, and again because of this, because this is energy, right? So any energy, as I told you before, the energy must be in joule. Okay, so that's the summarize what is the type of energy, okay, and what you will learn. Okay, so we move on to the last part. Okay, the last part of the teacher, is the longer or the more the force, the more the energy. Which type of energy that you talk about, whether it's potential or gravitational, elastic or kinetic? Elastic, yes. Okay, if the spring become longer or you give more force to the spring, okay, the energy will become higher. Correct. Okay, because they refer to this formula, right? So when the X increase, okay, this one also should be increased. If the F increase, this one also should be increased. Okay, this is actually the directly proportional, okay, relationship. Okay, very good question. Okay, any other question you want to ask? Before I move on to the last part, there is a principle conservation of energy. No. Okay. So let's see the last part for the chapter 7, there is a principle of conservation of energy. Okay, since because in this chapter we focus only based from the three energy, right? There is a gravitational potential energy, elastic potential energy, and kinetic potential energy, right? So because we only focus on that three, so the example that we use in the principle of conservation of energy, we only focus on that three types of energy. But actually there are more, there are many types of energy, right? Like we see, we learn in the power plant, right? In the power plant, there are type, like from heat change to kinetic, and then kinetic change to electrical energy. Okay, so that is also using the principle conservation of energy. Okay, so what does it mean by principle of conservation of energy? Okay, first you have to know the energy cannot be created. All right, it cannot be created, and also it cannot be destroyed. So what energy can do? The energy only can change form. Okay, so very easy. The easy example so that I can give, they say if you heat up the water, okay, using the kettle. Okay, so the first one, okay, where does the energy come from? It comes from the electrical energy. Right, when you switch on the current, so the current flows means there is electrical energy. Then the electrical energy will change to heat energy, right, to heat up the water. So that is the example how does the energy change form, okay, from the electrical energy to the heat energy. And also the energy cannot be destroyed, right? So we assume that every energy that being given by the that be given to the kettle, there is electrical energy. So the electrical energy is equals to the heat energy, right? We assume that one. Okay, but then of course there will be the heat loss to the surrounding also. Okay, so that is the loss of energy. But principle of conservation of energy said, okay, uh, the energy will be conserved, right? The energy will be conserved, okay. There is no loss, okay, means all the energy, okay, will only change form. Okay, so means that electrical energy goes to the heat energy. Or you can say, let's say you take a stairs, okay, you go up, okay, using a stairs. So first it comes from the chemical energy, come from the food that we eat. Then the chemical energy, when you start to climb the stairs, okay, the chemical energy, okay, change to the gravitational potential energy, because now your position is different, right? So that one they have the gravitational potential energy. So let's say if you reach at the third floor, okay, now it become no. Starting from the chemical energy, so when you try to climb down the stairs, it will change to kinetic energy first. Okay, kinetic energy first. Then let's say if you you arrive at third floor. So now you have the gravitational potential energy. So it only change form. Okay, you cannot destroy, you cannot create it. So that is the principle of conservation of energy. So the amount of energy in the universe is constant. Alright, and the principle of conservation of energy states the energy can neither be created or not destroyed. Okay, but energy change from one form to another. Okay, this one I already explained. So example, chemical energy to light energy. Let's say you use a battery, okay, to light up the torchlight. Okay, so now inside the battery they have the chemical energy. Okay, then when you switch on, okay, it will change to light energy. So that's the example. And another one is the gravitational potential energy to kinetic energy. So let's say you jump. Okay, so when you jump, of course you have to jump from the higher place, right? So you have the gravitational potential energy at that time. So when you jump, okay, now the gravitational potential energy is changed to kinetic energy. Right. And the next one is the gravitational potential energy to electrical energy. So this is also the change of energy. So let's say this one used in the hydroelectric power station. Okay. So I already told you they will put the water dam, okay, at the higher place. Okay. So now the water dam has a gravitational potential energy. So when the water comes, okay, when the water comes down, okay, the gravitational potential energy will change to kinetic energy. Then it will rotate the turbine, right? And the generator will produce the electricity. Okay, so this is the actually the conversion of the energy, the example. Okay, so the next one is says the oscillating system. Because we only learn three energy, so the example we can take is the oscillating system. So the oscillating system such as oscillation of simple pendulum, okay, and the oscillation of the loaded spring always experience transformation in the form of energy between gravitational potential energy or elastic potential energy and also kinetic energy. So we use this example, the oscillation, okay, to describe the change of energy between these three energy. Okay.
We have already learned that energy occurs in different forms, like kinetic energy, potential energy, light energy, heat energy, etc. Generally, the energy transfers between objects. For example, if you hit ball on the ground, energy has transferred from you to the ball, and the ball starts moving. The car engine burns the fuel in the car. Thus, fuel transforms from chemical energy to mechanical energy. The car starts moving. According to law of conservation of energy, the energy is not created nor destroyed, but it transforms from one form to another form. However, the total energy remains constant.
Okay. Alright. Says the energy will be conserved, right? It cannot be destroyed and it cannot be created, only change form. Okay, so let's see another slide. So oscillator system, okay, that obey the principle of conservation of energy. So the pendulum bob, right? So let's see if you try to oscillate the pendulum bob. Okay, we start from here first. Okay, so at this point, okay, there is no energy, okay, being applied to the system. Okay, and let's say after that, okay, I lift up the pendulum. Okay, let's say this is a pendulum A. Alright, then I lift up the pendulum at certain position. So I lift up until here. Okay, now you can see there is a change of energy. Okay, there is a change of energy. Right, there is a change of energy because there is a difference of height. So what is the energy that describe the position? What is the energy that due to its position? So the energy that due to its position is the gravitational potential energy. So when you lift up the pendulum bob here, okay, you lift up until certain position. So now at the position A here, okay, it will have the gravitational potential energy because the position is already changed. If not, if you don't apply to you don't apply a force to the pendulum, it will stay at the middle here, right? Okay, then you lift up, then the position is different now. So because of the position is different, we can say that at point A, okay, they have the gravitational potential energy. So the gravitational potential energy is maximum at A, but zero. Kinetic energy is zero. Okay. So the gravitational potential energy at A, okay, is maximum. Because I lift up, so means there is a change of position. So at position A, the GPE is maximum. Okay, GPE is gravitational potential energy. Okay, but you cannot put the short form in the question, in the answer. Okay, you have to put gravitational potential energy. Okay, so the gravitational potential energy is maximum at A because this lift up, because there is change of position, so means the GPE is maximum here. All right, and the KE is the kinetic energy. The kinetic energy is zero. Okay, so at this point, okay, now when you release the pendulum bob, what will happen? It will oscillate, right? It will oscillate like this. Okay, left, right, like that. So every time it move left to right, there will be change of energy. Okay, so every time it move left to right, it oscillate, it will have the change of energy. So we will see one by one. Okay, then after that, okay, after that you release the pendulum bob, it will go here, right, at the middle here. So at position, okay, we describe first from position A to B. So when the bob is released, it will go from position A to B. So at this time, okay, the energy will convert, right? So here you have to remember they have the high gravitational potential energy at position A. So when it comes down, okay, now all the gravitational potential energy is start to move, right? So remember, any object that move must have the kinetic energy. So all the GPE, okay, the gravitational potential energy, we start change to kinetic energy at point A to point B here. Okay, so you can see it said here. All right, the gravitational potential energy of Bob, GPE of Bob is decreasing because slowly all the GPE will change to kinetic energy. All the gravitational potential energy will change to kinetic energy. So the GPE will decrease while the KE kinetic energy will increase. Right? So the point A to B, the GPE will start to decrease because now they have to change to kinetic energy because there is a movement, right? There is a movement of the pendulum here. Okay, so when you start to release, it start to move. So means all the GPE change to KE, start to change, right? So the GPE decrease, the KE will increase. Okay, now at point B. So at point B, all the GPE, potential energy, change to KE already, means kinetic energy. So here at point B, the GPE is minimum, but the KE is maximum. Okay, so every time I put say KE, you already have to know that is a kinetic energy. Okay, so the KE is maximum at point B because all the GPE is already convert to kinetic energy at point B. So that's why KE is maximum, GPE is minimum. Okay, and then it's oscillate to C, right? It will oscillate to C here. So before it oscillate to C, okay, let's see what happened from position B to C. So this one you have to change, right? B to C. Okay, so when it start to change from B to C, remember at B, what is the energy, the highest energy that it has? It has the highest energy of the KE, right? So when it start to move to C, okay, you can see there is a change of position here, right? So now all the KE, okay, we change back to GPE. Okay, so it will change to gravitational potential energy because there is a change of position here. So all the kinetic energy started to change to GPE. So here at point B to C, the KE will decrease, all right, and GPE start to increase. All right, they change the energy because there is a due to its position, right? The energy is changed because of the position here. It increased. So when the position here increase means the GPE is start to increase, the KE is start to decrease because you have to know the energy can only change form, right? So if the GPE increase, the KE decrease. If the KE increase, the GPE decrease. All right, it only can be either that one. All right. Alright, so here from B to C, the GPE increase, the KE decrease. Okay, what happened to the at the point C? Okay, now at the point C, alright, all the energy from the KE here already changed completely to GPE, gravitational potential energy. So at this point, we can say the GPE is maximum, the KE is 0. Okay, the KE is 0. Alright, so now after that, of course, it will oscillate back. Okay, so this is C. Okay, we already described the GPE is maximum, the KE is 0. Alright, now it will move back. Okay, so when it move back at the from position C to B, okay, here I already said it has a high GPE, right? So when it start to move, okay, start to move from to B, the GPE will decrease, okay, and the KE will increase from point C to B. Okay, now the energy start to convert again. Okay, from GPE to KE. So from the position B to C, okay, the GPE decrease, the KE increase. Okay, and then at the position B. So at the position B again, at B now all the GPE from here completely changed to kinetic energy at point B. So here kinetic energy maximum, the gravitational potential energy is minimum at B. Okay, so it just repeat back, okay, like just now. Okay, and after that from point B to A. So from B to A, you can see it start to lift up again, got to go up again. So means there is a change of position here, right? So again, okay, the energy from the kinetic energy will decrease, okay, and the energy for the gravitational potential energy will increase from position B to A. The energy convert at this point, okay, from B to A. And again, the last one at position A, okay. So when it reach A, all the energy from the kinetic energy here already changed to gravitational potential energy at A. So all the energy already changed. So let's say this is 50 joule of energy, kinetic energy. So at point A, the gravitational potential energy is 50 joule. All the kinetic energy already converted. Okay, at point B and A maybe half. Okay, they are in the process to change the energy. So at the point A again, the GPE is maximum, the KE is 0. So that's how does the energy converted in the pendulum. Okay, by using the simple simple pendulum oscillation. Okay, now, right, we have to see for the spring, right? Because just now we only discussed for gravitational potential energy and kinetic energy. We still didn't discuss about the elastic potential energy. So for this one, we take the example for the spring, okay, and I put the load. So remember I said the elastic potential energy, okay, you can say that the spring has the elastic potential energy when you put the load, okay. So when you release the load, now it will become kinetic energy because the spring will move back to its original position. So spring have the elastic potential energy when it's stretching or compressed. But if you remove it, okay, if we go back to its original position, it doesn't have the elastic potential energy anymore. Okay, so the spring, we said it has the elastic potential energy when the spring is compressed or being stretched. Okay, so at position A, you put the load. Of course, you put the load, you already know. Now the spring has the elastic potential energy because it will be stretched. Okay. So at point A, okay, A, the EPE is the elastic potential energy, okay. The EPE is maximum because the spring is more stretched at this time, all right. And the KE is 0 because the spring is not moved now, right? Okay, so the elastic potential energy is maximum, okay, because the spring is stretched now, okay, at the highest displacement, okay, and the kinetic energy is zero. And then okay, after that, okay, from position A to B, okay, so from position A to B, so this is the equilibrium position, okay, so let's say if I take the load, okay, and it will release it, okay, I release it, uh, then it will go to B, okay, so when we go to B here, from position A to B, all right, from position B to E, just now from A, they got the elastic potential energy, right? So when it goes to B, now it start to move. All right. So the elastic potential energy is start to decrease. The KE is start to increase because the spring is start to move. Okay. And after that, when you reach at the position B, all the EPE, the elastic potential energy, will change to kinetic energy. So at that moment, the kinetic energy is maximum and the elastic potential energy is minimum. Okay, so I repeat again, at position A, because the spring is more stretched at that time. Okay, so you said it has the elastic potential energy and the kinetic energy is zero because the spring is not moving. So this is the release. Okay, if we goes to B, so at the B is the equilibrium position. So from A to B, now the spring move, right? So means the kinetic energy is increasing. So the the EPE, elastic potential energy, have to be decreased. Okay, then after it reach at the position B, okay, so when you reach at the position B, all the elastic potential energy now already changed to KE, to kinetic energy. So the elastic potential energy is minimum at this time, but the KE is maximum. Okay, so I repeat again, at A they have the elastic potential energy highest, okay, and kinetic energy is zero. Okay, so when you move here, now start to move, KE is increased. So from A to B, okay, the KE is increased and the EPE is decreased, okay, from position A to B. So when it at position B, now all the EPE change to kinetic energy. So kinetic energy is maximum at B, but the EPE is minimum. Wait for a moment. Wait, I have to change the laptop. Wait, I try to use another laptop here. I'm sorry. Okay. I will share your screen. Okay. I share the screen using my another laptop. Okay. Okay, so skip this one. Okay. Okay. So I think I stop until at position B, right? Okay. So now from position B to C. Okay. So remember just now at position B, so what does the energy, okay, consist at the position B? So here I explain again, this one they have the EPE. Okay, EPE maximum, KE is zero because the spring is not moved. So when you release, it's go to B. Alright. So when you go to B here, all right, from A to B, then it start to move, means the KE is start to increasing, the GPE is decrease. Okay. At the point B, all the EPE change to KE already. So at B, the KE is maximum. Okay, now because there is a change of position here, right? Now all the KE will decreasing, but the GPE will increase. Okay, so the EPE will increase. Okay, from B to C. So at the position B to C, now the energy start to convert again. So here they have the highest kinetic energy. So from E want to go to C. So here from B to C, the kinetic energy decreasing, the elastic potential energy is increasing here. So at the point C, now that we have the highest, okay, highest EPE, okay, elastic potential energy, okay, okay, okay. So at C here, okay, at point C here, okay. So at point C here, all the energy already, okay, changed to the elastic potential energy, and the KE will become 0. Okay, so that is the change of energy at point C. So I repeat again, A, EPE maximum, okay, EPE maximum at A, alright, and from A to B, the EPE minimum, okay, the KE, okay, start to increase, the EPE start to decrease. So here the KE maximum. So at KE, okay, from B to C, okay, the KE decreasing, alright, the EPE start to increase. Okay, and at point C, all the KE already changed to EPE. So the EPE is maximum, the KE is 0. Okay, now from point C to B. So remember, from point C to B, so at C, there has the highest highest EPE, right? So from point C to B, it changed back. Okay, so it start to move here. So the kinetic energy will increase, but the EPE will decrease. Okay, so at position B again, now it has the highest kinetic energy, but the EPE is minimum here. Okay, then it go back to position B to A, the KE will start decrease, but the EPE will start increase. Right, so at position A, it go back, the EPE is maximum, the KE is 0. So that's how does the energy change from the EPE, elastic potential energy, to kinetic energy. Okay, so the transformation of energy between potential energy and kinetic energy in a closed system obey the principle of conservation of energy. Okay, so means closed system there is no external force. Only these two force that being applied to the system. Okay, so you don't give any other type of force to the system. So that is a closed system. Alright, the total energy and potential energy is constant, okay, in a closed oscillation system, means there is no change. Let's say 50 joule of kinetic energy, 50 joule also for the potential energy. Okay, this is the summarize, okay. So at position O, okay, the PE minimum, KE maximum. Okay, at this point, the potential energy is maximum, K is 0. Alright, and this is the graph of transformation of energy. Alright, so let's say when this part, okay, this is the kinetic energy, right? Okay, so you can see the kinetic energy maximum, okay, and this is the potential energy. So the potential energy is, if the kinetic energy is maximum, the potential energy is minimum, is 0 here. So this is the graph of transformation of energy. Alright. So I just skip this one. Okay. So now we are finished. Okay. So I will give you the tutorial. All right. You can do during your tutorial time. We still got 50 minutes. Okay. I will assign in GC. So again, please answer in the test pad. So when the school open later, we will discuss for the tutorial. Okay, as usual. All right. So I will stop until now. All right. So thank you, class. All right. And happy holiday. Okay. So take care. Right. Stay safe, everyone. Okay. Bye-bye. Bye.